So we've looked at working with polar form and multiplication. What I'm going to do here, I'm going to give you a few exercises and questions to have a crack at. I want you to read the questions, pause the video, have a crack at them, and then come back and check your answers against my working. So here you go. So just 3 little questions for you based on the same 2 complex numbers. I've given you a Z1 and a Z2. I want you to calculate firstly Z1, Z2, then Z1 over Z2, and then last one, a bit of logic in it, Z1 squared. So pause the video and have a crack at that. First question, I wanted you to calculate Z1 times Z2. Now, remember the format for Z1, Z2, the quick and easy way, was to do AB bracket cos of big A plus big B plus I times sine of big A plus big B. All we had to do then was identify the wee a, wee b, big B, and then stick them in. So little a is with the Z1, little b is with the Z2, so it's 3 times 4, so that's 12, and then it's cos of a plus b, so pi over 3 plus pi over 6, that gives me 3 pi over 6, which is pi by 2. So that's then times cos of pi over 2 plus I sine pi over 2. What I then do is if it wants me to leave it in polar form, just leave it like that. If it wants me to take it a step further and calculate this and write it as simply as possible, I would just calculate cos of pi by 2 and sine pi by 2 and write it out. Cos of pi by 2 is equivalent to cos 90, which is 0. Sine pi by 2 equivalent to sine 90, which is 1. So I'd end up with just 12i. So there you go. First example done. Second one, if Z1 was the same and Z2 were the same as well, I want Z1 over Z2. Now remember for this one, the quick and easy way of doing it was A over B bracket cos. This time though it's A minus B, not A plus B, plus I times sine of A minus B. Now again, the small a, small b, big A, big B are going to stay the same because it's the same 2 complex numbers I'm working with. So in this case, what I'd end up getting is 3 over 4 bracket cos. I then have to do A minus B. So in this case, I do pi over 3, take away pi by 6. What that then leaves me with is just pi by 6. Then plus I times sine pi by 6. Again, if it wants it in polar form, leave it at this stage. If it doesn't, you can take it a step further and calculate each of those. So I'd get 3/4 bracket cos pi by 6 and sine pi by 6. So cos of pi by 6 is root 3 over 2, then plus I times sine of pi by 6, which is a half. So just make it look a little bit neater. I get 3/4 bracket root 3 over 2 plus a half I. So there you go, that's that one done. Third one I gave you was calculating Z1 squared. Now it requires a little bit of logical thought to set yourself up for this one, but the key thing to think about is the fact that Z1 squared is the equivalent of doing Z1 times Z1. I'm still going to use the same format, so I'm still going to use the AB times cos of big A plus big B plus I times the sine of big A plus big B. All I know now is that my little a and my little b and my big A and my big B are the same because they're all related to the Z1. So little a, little b are both equal to 3. So on the outside that's going to give me 9. It's then going to be times cos big A plus big B, pi over 3 plus pi over 3, cos of 2 pi by 3, plus I times sine of 2 pi by 3. Then we can leave it like that again if it wants it in polar form. If it doesn't and we have to go another step on, simply work it all through. What I'd end up getting for that is I'd end up getting 9 bracket negative a half plus root 3 over 2 times I. So there you go. That's what it will look like in standard polar form. Remembering the steps for this and remembering the quick formula and the quick way to go about it it's vital and it's key to be able to do, because it just makes our life a hell of a lot easier when working with complex numbers, particularly in polar form when we're doing multiplication operations with them and division. So just bear it in mind and try and keep it at the forefront when working with this.